Today we are going to be getting into a little bit of transformations and graphs. Specifically today we're just going to look at absolute values. So take your foldable. The way that you set it up is you're just going to fold it along the solid lines to make the flaps, and then you just cut along the dashed lines so that you can open up each individual flap and it will tell you about that particular transformation. So the transformations we're going to be looking at are vertical translations or shifts, and that can be up or down because vertical up or down. We also have horizontal shifts to the left or to the right. We have reflections either across the x-axis or the y-axis. We have vertical stretches and shrinks and horizontal stretches and shrinks. So all of this is going to be transforming our parent function for absolute values. So remember, our vertex is at the origin 0, 0, and then we're going up on either side, so it's always in the positive y, and so this is our reference point. This is our original parent function. So as we're talking about each transformation, that is the graph we are transforming. So let's start with our vertical shifts. So when you have your original function and function notation, if you are adding a positive value outside of your parentheses, that tells you are shifting up. So if my parent function is the absolute value of x, and I'm going to graph the absolute value of x plus 2 outside of my absolute value goalposts, that means when my original vertex was at 0, 0, I'm just going to go up 2 units. And then my graph, the rest of it looks exactly the same. Nothing else has changed. I just shifted it up 2. Similarly, if you are subtracting a value outside your parentheses, for example, the absolute value of x minus 1, that tells me I am shifting down. So when my original vertex was at 0, 0, I'm going to go down 1 unit to negative 1. And then the rest of my graph looks the same. So shifting up or down is if you are adding or subtracting a value outside of your parentheses, outside of your function notation. Now, what about a horizontal shift? Well, vertical was outside of the parentheses. Horizontal is inside. So if we have a number being subtracted minus inside, that means we're shifting to the right. So if I have the absolute value of x minus 2 and the minus 2 is inside my absolute value, that means my original vertex being at 0, 0, I'm going to shift it to the right 1, 2. And then the rest of my function looks the same. Then a shift to the left would be if we are adding a number inside your parentheses or inside your goalposts. So if I have the absolute value of x plus 3 when my original vertex was at 0, 0, I'm going to go to the left 3 units, and the rest of my function looks the same. So horizontal shift is inside the parentheses, minus means we're shifting to the right, plus means we're shifting to the left. I apologize for that bell. Talk about reflections. I know I have a reflection when I'm involving a negative sign. So if I am adding a minus sign outside, that means I'm reflecting across the x-axis. So remember, this was my original parent function. Here's my x-axis. If I'm translating it across or reflecting it across the x-axis, that means it's going to flip upside down. So when the negative is outside, my origin's not changing, my vertex is not changing, but my graph is just flipping upside down. Now when the negative is inside, that means we are reflecting across the y-axis, and if I reflect this across the y-axis, it's going to look the same, and that's because it is symmetrical. So again, outside we're reflecting across the x-axis, inside we're reflecting across the y-axis. Okay. Now, vertical stretches and shrinks. Remember, the negative tells us if we are reflecting across an axis. So for stretches and shrinks, the announcement started interrupting me. So remember, the negative tells us if we have a reflection on an axis. So when we are looking at stretches, we're not paying attention to if the number in front is positive or negative. We're just looking at the number itself. If it's outside, we're multiplying by a value that's bigger than 1. That means we are stretching vertically. So if I have 2 times the absolute value of x, what that means is it's going to get taller faster. So my origin's not changing, my vertex is not changing, but I'm going to be getting skinnier. I'm going to be getting taller. So again, I'm not looking at the sign. Negative tells me a reflection, but if I have a value smaller than 1, meaning a fraction being multiplied outside, then that is a vertical shrink. So it's getting shorter, it's getting fatter, it's getting wider, the opposite of a stretch. But the vertex isn't changing, we're just getting wider, shorter, fatter, however you want to say it. Okay, so that's when we're multiplying outside. That means vertical stretch or shrink. Whether you have a number bigger than 1 or less than 1 tells you if you are stretching or shrinking. And then last but not least, we have horizontal stretches and shrinks. So when we're multiplying outside, that is a vertical. When it's inside, it is horizontal, and it follows the opposite rules. When the number is a fraction, so again, the sign would tell us a reflection, so we're just looking at the value itself. If it is between 0 and 1, meaning it's a fraction, that means I have a stretch. I'm getting wider. And again, if I'm multiplying inside with a value bigger than 1, then that means it is shrinking horizontally. It's getting more narrow. So looking here, a vertical stretch and a horizontal shrink produce the same type of change. And a vertical shrink and a horizontal stretch produce the same type of change. What's different about it is the notation. Multiplying outside by a number bigger than 1 means vertical. Multiplying inside by a number bigger than 1 means horizontal. Multiplying outside by a number less than 1 is vertical. Multiplying inside by a number less than 1 is horizontal. But they produce the same visible change to our graph. Okay, so this is just transformations with absolute value functions for now. We'll be getting into more of them with our other parent functions later, but what you need to focus on is identifying what transformations are occurring given the transformed function.